The goal of this video is to show you how to make your Python code faster. And the technique that we use to do that is called vectorization. And what is Python vectorization, for example, or vectorization at large? Vectorization is the process of performing computation on a set of values at once instead of explicitly looping through individual elements one at a time. And this is an illustration of how vectorization works compared to non-vectorized operation. So in a non-vectorized operation, you have two vectors, for example. This could be two lists that you are trying to multiply. In the non-vectorized operation, you will need to carry out each operation separately. So you have to do operation 1 first, then move to operation 2, to operation 3, and to the last operation. But in the vectorized operation, everything happens at once. So instead of having 5 operations in the non-vectorized, you will have one operation in the vectorized. And the difference between vectorized and non-vectorized, for example, in Python, we have like the loop, which is the for loop, and the vectorized will be using libraries like numpy to vectorize the operations. And we're going to see the examples clearer. Now, in the first example that we're going to see here, this is an example of a loop operation. And we're going to run it and see the difference in the time between when we use loop and when we vectorize. In this operation, we create this list from 0 to 1 million. So we have 1 million values in the right sequence starting from 0. And here we have the time to be able to check. So we have the start time and we have the end time. So we want to see the difference in the start time and the end time to know the total time used for the loop. And this operation will be to have the square of each of the number in the 1 million values. So we are going to run this for you to see using for loop. And if you want to understand for loop better, there's a video on for loop on this channel that you can see to help you understand it better. Now, if I run this operation, okay, I'm getting this error, and that is because I didn't run my library here. So I have the import time, import numpy. Now that I've run that, I'll move back and I'll run this loop again. And you can see here, it took 0.14 seconds, for example. Now, this looks like it doesn't take a long time, but when we vectorize it, we will see the huge difference between them. So I'll move to the vectorized operation. And in the vectorized operation, here, instead of using it as a regular list, we are converting that same list into a numpy array. And that's where we use np.array numbers. Then we use the start time to check. And there we just have just a single operation. Instead of using for loop, we just say the array raised to power 2, because you use these two asterisks to show raised to power when you want to square a value or you want to raise it to the power of any number. So when we do this, you see we have 0.02 seconds. So compared to 0.14. So when you scale that operation, you will see that it is huge difference. It is about 12 times faster when you scale the operation into bigger level of operation. So you can see the difference between the loop and the vectorized. So let's move to another example. In the example 2, here you can see the loop operation here. What we want to do here is to find the even numbers in a list of about 1 million values. So we are going to run that. So we use for loop again, and we say if it is even, that is, if it is divisible by 2, append it into the list. So when we run this, it took about 0.09 to get that done. But when we go to the vectorized, now in the vectorized, we just convert it to numpy array. That is what we do. Then we just say evens, the name of the list. Then we do the array and just pass it into the array and just say array divided by 2 equals 0. That is if there's a remainder or not. So if the remainder is 0, it means it is even number. So when I run this, you can see 0.02 compared to 0.09. So you can see the difference here now. So let's move to another example to help us understand it better. Example 3. So in this example, we create the list in the range of 1 million. Then what we are doing here is we want to ensure that the number is greater than 500,000. And if a specific number or a specific value is greater than 500,000, multiply it by 2. And that is what we are doing. Then If it is not, just append the value as is. So if it is less than 500,000, you append the value directly without doing any other thing. But if it is greater than 500,000, you should multiply it by 2 before adding it back into the result. So let's run this. So this took about 0.11 seconds. So if I move to the vectorized operation for us to see, you can see we converted a numpy array and we use the np where. So instead of doing the exact for loop and doing this if condition, we use the np where method in numpy. And the np where method is like where the array is greater than 500,000, multiply the array by 2, else return just that value of that array. It is that simple. Now, when we run the vectorized operation, you can see it took about 2 seconds. Then when we go back into the loop, you can see here it took about 0.11 seconds, while this took about 0.02 seconds. In previous examples, we've been using a regular list and converting them to numpy array. But how does vectorization work in pandas data frame? And to see that, we are going to check the example here. So here we create a data frame, and here we have the price and the quantity. And what this np.random.int is representing is generate values between 100 and 1000, and those values should be a length of 1 million. So generate 1 million values between 100 and 1000. Therefore, the quantity generate 1 million values between 1 and 10, and they have to be integer. So that is why it is random integers. So I'll run this and I'll move to the loop operation. So here we want to get what the total price will be when we multiply it by the quantity. That is price multiplied by quantity. So using normal for loop, we say for I in range length of the data frame, and then we say total dot append the price multiplied by the quantity. So it goes through each row, then do that operation. And here we have the total, we assign it to total. Now when we print this, let's see what happens. So see how long this is taking compared to when we will vectorize it, and we're going to see that in the next slide. So here you see the loop time is 8.56 seconds. So that's about 8 seconds or almost 9 seconds here. So let's look at the vectorized. So in the vectorized, we just say df total equals df price multiplied by df quantity. This is because this kind of operation by default has been vectorized in pandas. So pandas has vectorized some processes so that things can be faster. So when I run this, you see, it took about 0.005. It's like it didn't even take any time. That's basically 0 seconds compared to 8 seconds. So let's look at another example. In the other example, look at this. What we want to do here is we want to remove 10% from the price if the price is greater than 500. So that is retain 90% of the price and let 10% go away so long the price is greater than 500. So here we run the code and let's see what happens by applying this 10% discount. So it took 0.43. But when we go to vectorize the operation and we run it, it took just 0.01. That is huge. That is very huge. So that is the beauty of vectorization. So I have a task for you. Look at this. I want you to vectorize this for loop and check the time and compare both. Then put your code in the comment section for me to see. So if this video has helped you, feel free to like it, subscribe, and also share with other people that could learn from it. So thank you and see you in the next video.